So today I'm going to explain the Dbscan, which stands for the density-based spatial clustering application. Dbscan is a popular clustering algorithm used in the data mining and machine learning. Okay, it was proposed by Martin Easter and Hans Peter Kriegel, Georg Sander and Xiao Yuzu in 1996. Exactly. The main purpose of Dbscan is to identify the cluster in the dataset based on the density. Unlike many clustering algorithms, Dbscan can find clusters of any shape. And we can also collect the data and to detect the noise into the outlier density points. Understood? It separates high density regions into similar low density regions, making it very useful for analyzing real world data. In simple words, or in simple word, DBs can group similar data points together while identifying the unusual isolated data points, which can be considered as a DB scan. So now we can focusing on parameter of DB scan. There are two special parameter. The first parameter is Appleson, also called as F, and F is defined the neighborhood radius, which is a data point to two points are considered as a neighbors. Okay, if the distance between that them less than equal to or the x value. Understood? So the second parameter is minimum point, and which is stand for the minimum point, and we called as a min point, MINPTS, which helps to the represent the minimum number of neighboring point required to the radius of a point to be considered part of the cluster. Understood? The common rule minimum point is nothing but a greater than d plus 1, where d represents the number of dimensions in the data set. Choosing the appropriate value for like for the Appleson, we are considered as a they directly affect the quality of clustering result. Now, this is a types of data points. Exactly what type of data points we are considering in a DB scan. There are total three types of core. There are total of three data points: core point, border point, and a noise or outlier. So the core point is nothing but a core point at least minimum point with its Appleson neighborhood, including itself. These points are called a central part of a cluster. Understood? Then border point. Border point is nothing but a minimum point, neighboring point but lies within the neighbors and of a core point. Noise or outlier. It is nothing but a noise and it is clearly instruction that it treated as an anomaly or outlier. Understanding these three types of points, we are essential for understanding how DBs can create clusters because it is an unsupervised machine learning and we can create a clusters. So like that, we are basically focus on core point, border point, and noise or outlier. Second one is the example core point, border point, and outlier which is shown into a particular diagram. The red point represent a core point because they sufficient neighboring within the specified radius. The yellow point shows the border point because they are connected to a cluster but do not have enough neighbors to become core points. And the blue point and the last point which represent as a outlier point because it is isolated and does not belong to any cluster. So this is the best example to visualize exactly how DBs can identify the clusters and based on the density rather than the predefined shape. The best example of this customer segmentation. Likewise, we are doing the customer segmentation in this scenario. Understood? And the last one is exactly the understand the DB scan. Here I am mentioning the all the points exactly. First is algorithm select a random unvisited point and check its neighborhood using the Appleson parameter. Second point, it considered as a minimum point. It become a core point and a new cluster created. Okay. So the next is all neighboring points are then added to that make a cluster. This process continues until density connected points are included in this cluster. Okay. The and the last point is nothing but a It is a as a Dbscan successfully identifies the cluster and separates the outliers from meaningful groups. So that is how we are making a Dbscan algorithm. Hope you like this video. Thank you so much.